Click for IB Biology. Methods of calculating the rate of reaction. We're going to look at endpoint determination method and the initial rate of reaction method. Compare the two. There's a PDF of this presentation in the description of the video, along with a quiz where you'll be able to answer questions with answers to find out, check your understanding of what's going on in this video. So let's take a look first of all at endpoint determinations. And the classic experiment in this nature is the conversion of starch to maltose by amylase. So of course what happens when we do this experiment is that as the amylase turns the starch into maltose, the maltose concentration increases and the starch concentration decreases. But normally when this experiment is done, we use iodine to test for the presence of starch. And so as the experiment proceeds, the concentration of starch decreases, but we don't actually get to the end of the experiment, the end point, until this point here, which would then give us a time for the purposes of calculating rate. Now the problem with this type of experiment is that the length of reaction is so long that the conditions which you have set up experimentally, such as the concentration of the starch, the volume of the starch, the concentration of the enzyme, and the volume of the enzyme, these have changed during the course of the experiment. And so the conditions operating by the time you get to the end are not the conditions that you set up in your experiment. So this introduces a large error to the experimental method, and so when we calculate rate as 1 over time, that error is included in this this methodology. The advantage of this method is it's a very simple technique. Often these are very simple, but they contain large errors. Let's compare that to an example of initial rate of reaction calculations. Here, I'm going to take hydrogen peroxide and break it down into oxygen and water through the action of the enzyme catalase. Now, with this, what I'm going to measure is the production of oxygen. And here, we're collecting the oxygen over water. Here, the oxygen is produced in the reaction here through the delivery tube, delivers the oxygen to this burette, and the markings on the burette allow me to, that through time, I can record the accumulating volume of oxygen as the experiment proceeds, including straight away. When plotted on a graph like so, classically one would get this kind of curve, and the initial conditions set up over here, which as before is the concentration and volume of peroxide, the concentration and volume of the catalase, which were defined in the method, these exist at this point in time here. So by taking the tangent to the curve, we can find the gradient of the curve. The gradient is the rate, and so we've now calculated the initial rate of reaction, which gives us a better measure of the rate of reaction of the enzyme under the conditions specified by the experiment. Although, as you can see, this type of experiment involves more data processing and more elaborate methods. But by and large, it will give you a better estimate of the initial rate of reaction. Things to consider when you're designing your IA or interpreting questions, perhaps in paper 1B, or indeed other parts of the examination. The final video on enzymes is shown in the link here, along with a subscription button should you wish to subscribe to this channel, and a link back to the playlist so that you can look through the different enzyme videos and different playlists available on this Click for IB Biology site.